Okay, but now we are going to do a little bit of work with chapter 5. So you've got your colored sheets with you, and you are going to reference those a lot as we go through. Okay, so so here we go. Number 1. Some people consider this to be one of the hardest things we do all year. Luckily, it's only one section, and then the rest of the chapter is pretty easy. And we only do 3 sections in this class. So you've noticed probably your homework packet's pretty small because there's only 3 sections worth of homework in there. But this first one is a little bit on the tricky side. So here we go. We have sine cubed plus sine cosine squared. Now, one thing I want to make sure we're clear on is that when we are writing trigonometric expressions, when we want to square them or cube them or something, like this right here, this means the sine of x cubed. And if you want to write it that way, if it's easier for you to think of it like that, that's fine. I will never do that. Your book won't do that. This is the way it's normally written, but this is what it means. You cannot write this. Can somebody tell me why that would not be acceptable?
Because you know using the 3 on the x.
Exactly. It looks like it's x cubed and not the sine cubed. When we mean sine cubed, we put the cube on the sine. That means sine cubed. That means this. These are the same thing. Okay. Now the directions say simplify. So when I look at this, the first thing that occurs to me is I could factor out a sine x. I can take one of these out, and that will leave me with 2 of them. And I can take this out, and that would leave me with just the cosine. Now, does that make sense to you? I factored out one of the sines. So pulled one out of here, it left me with 2 left. Pulled that out of here, it left me with just the cosines. Now, I want you to look, and today we're looking at our colored sheet, but we're only looking at the first, let's see, 1, 2, 3, 4, 5, 6, 8. The first 8 in the first column. That's where our focus is today. The first 8 in the first column. So I want you to look at those first 8 in the first column and tell me if you see anything that looks like this.
In the 5th one, it says sine 2, 0 plus cosine 2, 0 equals 1.
Okay, so let's say that right. It's sine squared theta
Oh.
plus cosine squared theta equals 1. What that means is every time you have a sine squared plus a cosine squared, you can replace it with 1. This is just 1. So the answer to your problem is sine x times 1, which is just sine x. You are not solving this, so it's not like you're going to get x equals 5 or something. You're just simplifying it. So we started with this big, hard-looking expression, and we factored out a sign, and then notice that what we have left is 1. So the answer is sine times 1, which is just sine.
Where on our reference sheet are we looking again?
Okay? We have the first column, the first 8.
Okay.
All right. Now, let's look at the next one and see if we can simplify it. So we have secant plus 1, secant minus 1 over sine squared. All right, so here we go. Take a look at the problem. What could you do to get started? What's something that it looks like you could do to get going on this?
Could you multiply by sine 2 to get rid of the fraction?
Well, you can't really do that when it's not an equation. So like,
Take out the secant.
Ari, if you had the number 3/2, you can't just multiply it by 2. You have to have an equation, you know, like this, and then you can multiply by 2. But we can't really get rid of the fraction here. What was the second suggestion?
Take out the secant.
Well, it's already factored up there. There's 2 factors up there, 2 parentheses. So I can't really factor out anything from it because it's already been factored. I wonder if I could FOIL them together though. Does that FOIL? Could I FOIL that together?
Yeah.
All right, what would I have if I did that? If I did first outside, inside, last, what am I going to end up with? Secant times secant is secant squared. That's exactly right. And remember, we're writing it like this, secant squared. All right, now, outsides minus secant x. What are insides?
Plus secant.
Uh-huh. And last gives me minus 1. Now, does anything simplify? Look at it now that you FOILed it out up there on the top. Does anything fact or cancel or do anything? Can you do anything with it?
Secant x.
Secants.
These guys cancel, right. So we're left with secant squared minus 1 over sine squared. Now, we're not done yet, but it's cleaned up a little bit. Looks a little bit better than it did. Now, I want you to look at your sheet again. And remember, we're only looking at the first few in that first column. Do you see any of those identities, any of those equations that have a secant squared and a 1 in them?
The 8.
Okay, what does it say?
1 plus.
Tangent squared is secant squared, right? Now, that's not exactly what I have here, but could I subtract this 1 to the other side? And then it would say tangent squared equals secant squared minus 1. So this secant squared minus 1 that's in my problem, I can change into a tangent squared. So right on your blue sheet or yellow or orange, whatever color it is, right on your colored sheet, right next to this one, why don't you write this? Because it's the same formula, the same identity, it's just written in a different order. And you want to be able to use it both ways. So these are the same identity, just rearranged a little bit. All right, so now I need you to look in your first column again. And I want you to tell me if you see anything about tangent. Look in the first column. Does it give you any information about the regular tangent? Not tangent squared, just the regular tangent. What does it say about tangent?
Cosine.
Say that again.
Sine over cosine.
Cosine. That's exactly right. Tangent, kids, is sine over cosine. You really want to start getting the feel for these. And I know this is day one. I don't want you to panic about it or worry about it. But after our test, I want you to get serious about learning that tangent squared is sine squared over cosine squared. Now, this is a mess, but I've rewritten tangent squared as sine squared over cosine squared. Now I need you to hang in there and pay attention. This means sine squared over cosine squared divided by sine squared. That's what this says. It says take this guy and divide him by this guy. Well, we know that dividing is the same as multiplying by the reciprocal. So instead of dividing by sine squared over 1, I'm going to multiply by 1 over sine squared. And what's going to happen when I do that?
The signs will cancel out.
Exactly. And I will be left with 1 over cosine squared. So I erased my problem, but that big, huge problem that we started with in number 2, it has now boiled down to just this. If you wanted to, you could write that as secant squared. You don't have to, but isn't 1 over cosine the same as secant? Secant is the reciprocal of the cosine. So either one of those are a good ending point.
Wait, why is it 1 over cosine if we're multiplying the sets?
Okay, multiply straight across. So you have sine squared times 1 over cosine squared sine squared. So the sine squareds cancel. Where's the cosine? It's in the denominator.
Oh, okay.
I hope that you'll all use lots of paper when you do this, lots of space. Don't try to cram it all in, or these are too long. You need to have lots of room to work. And write down every step. Okay, problem 3. Does anything cancel in this problem? Look at my head. Does anything cancel in this problem? No, you cannot cancel. This is a minus sign. If it's a times, you can cancel. But when it's a minus, there's no canceling. What are we going to do instead?
Combine.
Okay. How do I do that? What will I have to do to combine?
Cross multiply.
Okay, can't cross multiply because it's not an equal sign. To cross multiply, you have to have something that looks like this. All right, that I could cross multiply because there's an equals. when you have a fraction minus another fraction, you don't cross multiply. What do you do when you subtract fractions?
Get a common denominator.
Exactly. Exactly. Gang, these problems look a whole lot harder, but they use the very same skills you've always used. You are subtracting fractions, you need a common denominator. And your common denominator is going to be 1 minus sine times cosine. That and that are going to be your common denominator. So, to make both of these have that denominator, this one is going to have to be multiplied by cosine, right? Now it has the denominator, and this one is going to have to be multiplied by 1 minus sine. And now it has the denominator. Would everybody agree that both fractions now have the common denominator? So just like you would multiply over here, this one by 4 and this one by 5, you multiply this one by cosine and this one by 1 minus sine. Now, what does that make the numerators? Okay, so here's our first fraction. We multiplied top and bottom by cosine. So what do I have now on the top?
Cosine squared.
Exactly, cosine squared x, perfect. Then I have my minus sign. All right, now what do I have here? I'm going to distribute, would you agree? I'm going to distribute on the top. So that's going to be minus sine, and then plus sine squared. And this is where you might get confused. Remember, this is a negative out here. So think of it as plus or minus. So you have negative sine times 1. That's negative sine. Then you have negative sine times negative sine. That's plus sine squared. Did you follow that? Now I want you to look on your sheet for a second. And I want you to look in that first column. And do you see anything about having a cosine squared plus a sine squared together in the problem? What does it say about cosine squared plus sine squared?
Equals 1.
It equals 1.
It equals 1. So now I'm going to take those two circled things and I'm going to write it as 1 minus sine, because this makes a 1, and then I have my minus sine, over 1 minus sine cosine. Would you notice anything about that? Look at that carefully. What do you notice about it? You notice
It
it?
cancels out.
Exactly. Thank you very much. It cancels out. Okay. So when I cancel those out, please remember that when you cancel out the whole thing, you have to put a 1. So you cancel out the entire parentheses, 1 minus sine. That leaves us with a 1 on top and a cosine on the bottom, which you can
Miss Ford, Jada wanted me to tell you
I
her
just
iPad
got
just died. She's trying to rejoin.
She is, I got her. She's in. Okay. So what's another way of writing 1 over cosine? It is fine to leave it as 1 over cosine, but how else could you write it if you wanted to?
Secant?
Yeah, so if you want to write that as secant, you can, but you certainly don't have to. 1 over cosine is fine. All right, now we've got a couple,
Could you just leave it as 1 over cosine x?
okay, what did I say? Yes, I said that was fine. Okay, now let's look at the next one because it looks a little different, but actually it's easier. So we've got cotangent over cosecant. Now, remember, when you say over, you mean divided by, right? So this is cotangent divided by cosecant. That's it. That's how you need to think about this. This is a division problem. Now, look at your sheet. Look at the first column. What does it say about cotangent? Not cotangent squared, but just plain cotangent. What does it say?
Cotangent theta equals cosine over sine.
Ah, so I'm going to think of this as cosine over sine, because that is what cotangent is. That is another definition of cotangent. Cosine over sine. What?
Or would it be divided by cosecant x?
Well, now what is cosecant? What's cosecant?
1 over sine theta.
Okay, so you have cosine divided by sine divided by 1 over sine. That's a division problem. So it's cosine over sine divided by 1 over sine. Well, what happens when I divide by a fraction? What do? I don't divide by a fraction. What do?
Did you multiply by the reciprocal?
Exactly. And what happens when I multiply by sine over 1? This is a multiply now. What happens?
Cancel.
Exactly. And the final answer to the problem is just cosine. That's all that's left. So you started with this, but by rewriting cotangent as cosine over sine and rewriting cosecant as 1 over sine, and then flipping and multiplying, you ended up with just cosine. That's not too bad, is it? Let's try 5, because it looks very, very similar.
Wouldn't it be 1 sine x divided by 1 cosine x?
So it's 1 over sine theta, which you can use x. You definitely can use x. You don't have to use thetas. You can use x. I'll use theta because that's where I've gotten the problem. But it's 1 over sine theta divided by 1 over cosine theta, because the problem is cosecant divided by secant. Cosecant is 1 over sine divided by 1 over cosine. Now again, we've got division by a fraction. So I'll say 1 over sine times cosine over 1. Is that okay with everybody? Now, nothing's going to cancel, so I'm just going to multiply straight across, and I have cosine on top and sine on the bottom. Would you agree with that? Look at your sheet. When you have a cosine over a sine, what do you have? Cotangent. So that one simplifies down to cotangent. Number 5 just comes down to cotangent. I totally promise, guys, these are gonna get easier. And before we have any kind of an assessment, we'll practice and practice and practice. But I will say this, your life is gonna be a whole lot easier. You're gonna pick it up a lot easier if you get those first 8 memorized.
What was the answer to that one?
I don't know what I end up with. A cotangent, cotangent. All right, now we got kind of a tricky one. I don't know what to do. So I am going to look at my colored sheet and I'm going to see if there is anything on the sheet, and I'm looking at just those first 8. In the first column, the first 8, don't be looking at the whole sheet. Is there anything in those first few identities that involves a cosine squared?
Sine squared. Theta plus cosine, or sine squared plus cosine squared
Uh-huh,
equals 1.
uh-huh. Jada? Jada, are you okay? Who is that looking in the screen?
My baby brother.
Oh, okay. All right. So cosine squared plus sine squared is 1. Now I'm going to write that over here to the side, because this is a little trick you're going to have to be able to use. My problem, well, first of all, this is not a squared. So that's out of the picture right now. I'm looking at the numerator, which has a square. These are squares. All right? Now, I can rearrange this. I'm going to subtract sine squared from both sides. So this is on my sheet. It's fact. I'm subtracting it from both sides. Subtracting sine squared from both sides. So what does my equation look like now? If I subtract that away, it says cosine squared equals 1 minus sine squared. Would everybody agree that that is another version of that equation right there? Chase, I don't see you.
My phone's on the charger, so like it's in a bad spot.
Remember, if I don't see you, you're not present. So you gotta get this figured out, Chase. And now, who else have I lost? You guys. Okay, all right, found it. Okay, so I am right on your paper where you see this one, write this next to it. Did we already write that down next to it? I can't remember. I know we wrote something down. Write this next to it if we haven't already. Then I'm going to come over here to my problem, and I'm going to take out this cosine squared, and I'm going to plug in 1 minus sine squared. So I'm like doing substitution. I'm taking out my cosine squared, and I'm substituting this in its place. Now, some of you are thinking, Mrs. Ford, why are you doing that? because I cannot cancel. So some of you might think, oh, she's going to try to cancel. No, I'm not, because you can't cancel anything in this problem because these are subtractions. You can only cancel if they're multiplies. But what I am going to do is factor the top. I will give a bonus point on the test tomorrow to anybody who can tell me how to factor that top. How does that factor?
1 plus and minus.
I love you, Ori. I love you. Remind me about that I owe you a bonus point, okay? Tomorrow, remind me. That's exactly how it factors. Boys and girls, this is a difference of squares. This is like 1 minus m squared. That would be 1 minus m, 1 plus m. Remember that? Or a squared minus b squared. A plus b, a minus b. That is exactly what this is. The difference of squares. So once I factor it, what's going to happen then? Right here.
You cancel it out. So
Now they
it's
cancel.
1 plus sign.
Exactly. So the answer is 1 plus sign. Once you factor, you are allowed to cancel. You can always cancel or try to cancel after you factor. All right, so 2 things came out of that problem. One is make sure that you've written this down on your colored sheet next to this identity. And the second thing is, anytime you use that, since it's a 1 minus sine squared, it will be factorable. 1 minus sine, 1 plus sine. Now, I'm not saying you're going to factor it every time, but you can. You can factor it. Beautiful, beautiful, beautiful. All right, let's see what's next. Number 7.
My Max about to die, so I'm gonna join on my phone.
Okay. All right, we've done a few of these. I know it's your first day. But does anybody have a thought on what we might do to get started? Just think about some of the things we've done already. What do you think might be?
Take out x.
All right, we can never factor out the angle. So when we factor, we would have to factor out a sine x, or a tangent x, or a cosine x. They are inseparable. They're not like separate pieces. They're one chunk. And since that's a sine, that's a tangent, that's a cosine, there really isn't anything common there. So I don't think I'll start by factoring.
Didn't you change tangent to sine x over cosine x?
Beautiful. Let's change tangent into sine x over cosine x. So I have sine over 1, that's my sine, times sine over cosine, that's my tangent. What happens when I multiply those 2 together? That's a multiplication. What do I get when I do that?
Sine x squared plus
Over cosine.
1 cosine.
Yep.
Or
You-
you don't have to put the 1 right?
Yeah, you don't need the 1. It's fine to put the 1, but you don't need it. So when I multiply these, I get sine squared. When I multiply these, I get cosine. All right, and it's still plus the cosine. Now we're back to a point where we were in another problem. I need to add these 2 things together. They're fractions. What do I need to do in order to add them together?
Can you cancel?
Can I what?
Cancel.
Okay, you can never cancel when there's a plus sign, so there's no
Yeah.
canceling.
Denominator.
I need a common denominator. I am gonna add these two fractions together. And guys, I cannot emphasize enough, anytime you're adding fractions, I don't care if you're in second grade or graduate school, when you're adding fractions, you need a common denominator. So this one has a denominator of cosine. This one has a denominator 1. So I'm going to multiply top and bottom by cosine, so that now they both have a denominator of cosine. Once you get the same denominator, you're going to write one fraction. That's why you did it, so you could put them together as one. So I'm putting them together as one fraction.
So would it be sine squared plus cosine squared?
Yes, it would, Mary Kate. And when you said that, it made my little heart go, woo, because what's sine squared plus cosine squared?
It's 1.
It's 1. So now you added this mess together, but you just end up with 1 over cosine, which is fine to leave. But if you want to impress somebody, you can say, oh, 1 over cosine is there we go. So let's go back and review the steps of that problem. What was the very first thing we did? We changed our tangent into sine over cosine. So then we multiplied these together, and we got sine squared over cosine plus our cosine. Then we said, hey, we've got two fractions, we need a common denominator. So we multiplied this one by cosine over cosine. And that gave us sine squared plus cosine squared, which is 1 over our cosine. Okay. Let's look at the next one. We're ready for number 8, I think. Cotangent sine plus tangent cosine. Now, here's another one. There is nothing to factor. Does everybody see that? You don't have any like terms. So you cannot factor in this problem.
Wouldn't it be cosine over sine times sine?
Okay, so does everybody understand what she's doing? She's saying, let's change cotangent into cosine over sine. Look at your sheet. Isn't that what cotangent is?
And then wouldn't it be sine over 1?
Yep, and we're going to multiply that by sine over 1. And the reason I'm writing it as sine over 1, well, first of all, Mary Kate told me to, but second of all, we're going to multiply these fractions together. So it's nice, since this one is a fraction, to write this one as a fraction, so I can multiply them together. Oh, wait, what's going to happen when I multiply those together?
Will the signs cancel?
They would. It's a multiplication. They cancel on a multiplication. So it's just cosine x. All right, now wait, I haven't done this side though. So here we go.
And then it'd be sine x over cosine x times cosine x over 1.
Perfect. Does everybody see where this is going to be handled just like this was? Except we got tangent, so it's sine over cosine.
And then the exact same thing happens. So it's going to be sine x over 1.
Yep.
which means that it's gonna equal 1.
Actually, it doesn't. Why does this not equal 1?
Oh, because it's not squared.
Exactly. So this one just equals cosine plus sine. You can only combine these when they're squared. When they're squared, you can combine them. Right now, we can't. So we just stop with cosine plus sine. All right, so we started with this. That didn't take us very long. We zipped through that one. Does anybody have a question about our steps here? I know your heads are spinning. Try to hang on to them. Don't let them fly off. We'll get it. You'll get it. The more we practice, the easier it gets. All right, what am I ready for? 9? Here we go. Now, I want you to look at your colored sheet. Just that first column, those first few I told you to look at. Do you see anything in this problem that's on that sheet? Annie's nodding. What are you seeing, Annie, that's on the sheet?
That the 1 plus tan to the second x equals secant squared theta.
Exactly. This is on your sheet, you guys. That is an identity, and it says, the sheet says, that 1 plus tangent squared x is the same as secant squared x. The variable doesn't matter, so please don't get confused if there's thetas on the paper and x's on the board. That doesn't matter. The letter doesn't matter. Does everybody see that identity that says 1 plus tangent squared is the same as secant squared? Okay, now tell me about secant. What is secant? What's another way of writing secant?
1 over cosecant.
1 over cosine.
Yeah.
Yeah. And since it's squared, it'll be 1 over cosine squared. Secant is the reciprocal of the cosine. That's on your paper too. Secant is 1 over cosine. So secant squared is 1 over cosine squared. Now, I'm going to multiply these. So I'm going to get cosine over cosine squared. I'm just multiplying straight across, right? What happens here? Come on, guys, hang with me. This is easy. You got cosines over 2 cosines. What's going to happen?
You can take out 1 cosine.
You can cancel, absolutely. Now, when I cancel, I'm going to have a 1 on the top because I'm taking him completely out. And then I'm going to have 1 cosine left over on the bottom. Would you agree? When I cancel that? Now, you can leave it as 1 over cosine, or again, you can write it as secant, since that's what 1 over cosine is. Okay, let's take a look at number 10. Anybody have an idea about number 10? I'll just be quiet and we'll go with your thoughts. Anybody have a thought about that? What we might do with that?
Would it be sine x over cosine x
So wait, let me catch up to you.
divided by 1 over cosine?
Exactly, and they're squared. So what Mary Kate's saying is tangent squared is sine squared over cosine squared. Okay, that's this right here. That's this. But we're dividing that by 1 over cosine squared. Because that's what secant is. Secant is 1 over cosine.
Would the 1 be squared too on the bottom?
This one?
Yeah.
You can do that. It technically
It's still
is.
gonna be a 1.
It's still going to be 1, right. So it doesn't matter. We don't normally put it there, but you can if you want. Now, this is where I want you to pay attention. Sine squared over cosine squared divided by 1 over cosine squared means I'm going to invert and multiply, right? I'm going to flip it over and multiply. So this is actually going to be sine squared over cosine squared times cosine squared over 1. Remember, when you divide by a fraction, you're really multiplying by the reciprocal. Okay, what happens?
The cosines cancel.
They do. And
So it's just sine squared
exactly.
x.
That's your answer, sine squared x. You can put it over 1 if you want, but we don't usually. We just usually write sine squared x. So who's got a question about that one? This is where we started. Are you kind of getting used to changing your things so tangent squared became sine squared over cosine squared? And secant squared became 1 over cosine squared? All right. That was a great idea. Thank you, Mary Kate, for getting us started on that problem. Let's give someone else a chance. Who sees something we could do with this problem? Look at it carefully. What do you think we maybe could do? Factor. This one we can factor because it has a sine squared in both pieces. So if we pull out our sine squared, or factor it out, we'll have left a secant squared minus 1. Remember, if you take out the whole thing, you have to put a 1. Let's look at our colored sheet, first column. What do you think about secant squared minus 1? Is that anywhere on the sheet?
Can it be tangent squared?
Exactly. Exactly. On the sheet, kids, this is work over to the side. On the sheet, it says 1 plus tangent squared is secant squared. That's what it says on the sheet. If we subtract the 1 from both sides, doesn't it say tangent squared equals secant squared minus 1? If we haven't already written this down next to this identity, would you do that? If you have, I can't remember which ones we've written down. If we haven't written this one down, write it next to this identity. It's a different version of this identity, and you need to be comfortable with it. So I'm going to come over here, and secant squared minus 1 is tangent squared? Those of you that go on to take a calculus class, you are going to need this stuff. All right, what do we do next? Do we have any ideas? Okay, what about tangent squared? What is tangent squared?
1 plus tangent squared equals secant squared.
Okay, that is true, but that would just bring me right back to where I was.
Okay,
Okay.
tangent equals sine over cosine.
That
so
sounds like a
tangent squared
plan.
would equal sine squared over cosine squared.
That sounds like a great plan. Now, what makes this one different is, I think in all of our other examples, when we made this change, we could cancel. In this problem, can we cancel? No, but we can still multiply. So what happens if we have sine squared times sine squared? What will that equal?
Sine to the 4th.
Yep, and we write it like that, sine to the 4th with the x. Don't forget the x, or the theta, whatever you're using. What's in the denominator?
Cosine squared.
Yep, and that's it. We're done. There's nothing else we can do to make that any simpler. That's as simple as it gets.
Miss Ford, can I
Yes.
please go to the bathroom?
Yes, we're going to do one more problem, and then you're all going to get to go to the bathroom. I don't care. Go ahead and go to the bathroom. We're going to do one more. We're going to do number 12. I want you to look at it carefully, and this actually can be a one-step problem if you have your thinking caps on. We have already talked about this concept earlier. First of all, don't you dare cancel anything. You cannot cancel anything unless, because of all those minus signs, the only way you can cancel is if you can do any factoring. Look at it carefully. Is there any factoring that we can do?
You do differences to those.
Yes, I love you guys. That's right. The top is the difference of squares. So how will that factor? It's a square minus a square. So how will that factor?
Plus 2 minus 2.
Cosine minus 2, cosine plus 2, in either order. It doesn't matter which order you do this. That's like a plus b, a minus b. And the denominator is cosine minus 2. So what's going to happen?
Cancel.
Yep. And the answer is just going to be the leftover parentheses, which is cosine plus 2. All right. All right, now someone else has left. So you guys can go as soon as I figure out who else has dropped out. Oh, I think it must have been Mary Kate. Okay. All right, so here's the deal. Next time I see you, which is Wednesday, we'll take our test. All right, you got tons of review material. We have office hours tomorrow. Actually, we have office hours Wednesday too, I think. So think about that, get your questions organized, do some review practice, do another practice test, and you'll be all set. I promise the test looks just like the practices, okay? All right, have a great day, you guys. Take care.
Thank you.
Thank you.
Bye-bye.